So as I mentioned, we're going to do a lab tomorrow or next time I see you. Kind of the foundation of that lab is this concept of ground versus excited state electrons. The main part, this is like a really brief overview of it. The main thing that you need to know is that when electrons get excited, I kind of compare it to students where they are not where they need to be. So, for example, on like the day before a break in any of your classes, students are like out of their seats or roaming the halls or just like up and about and generally excited, have more energy than they would normally have, and are not where they're supposed to be. Electrons do the same thing. So what we've learned so far, all of the electron configurations that we did higher up on this page were ground state electron configurations. This is the normal electron configuration for any element. It's the most stable, lowest energy arrangement of the electrons in an atom. So the electrons are in the correct order of orbitals. So what this compares to is, like on any given day, high school students generally do whatever it takes to expend the lowest amount of energy. They don't often want to get up out of their seats and get the paper that they need to get, or something along those lines. And then excited state electrons are going to be electrons that are out of their normal order. They have jumped up because of the increased energy that they now have, and they're sitting in energy levels or different orbitals where they wouldn't normally be. So excited state is when an atom gains energy, the electrons jump into higher energy levels, and so what this looks like is on your electron configuration, which of course I don't have any actually written on here. So let me just do one real quick. 1s2, 2s2, 2p6, 3s2, 3p5, 4s1. Okay. In this example, something that should stand out to you right away is that this P5 should not exist if something is after it, because in order to get to 4s, the 3p sublevel should have how many electrons? 6. So what it would normally be is 3p6, but instead what happened is that electron that should have been 3p6 got excited and jumped up to the next energy level and is hanging out in 4s. So what we do is we count up how many electrons there are to figure out what element this actually is. Whereas if I were to look at 4s1 on my periodic table, gotta pull up a little one. So if I'm in 4s1, that looks like it should be potassium. But if I count how many electrons are represented in this electron configuration, I have 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 5 would be 17, plus 1 would be 18. So 18 electrons tells me that I'm actually argon, but based on the placement of the electrons, it's hanging out and acting like it's going to be potassium. So the reason that that happens is because this electron configuration demonstrates an excited state, meaning that argon had to have gained energy and its electron jumped up to a higher energy level where it should not have been. Does that make sense? So I will not have you guys writing electron configuration for an excited state element, but I will have you recognizing it. And so what you're looking for in that case is an electron out of place. So we should, at this point, be comfortable with the fact that we can't get to the 4s sublevel or energy level and sublevel without 3p being full. So the fact that this is not full and that it's just a 5 tells me that something is out of place. So it is looking artificially higher than what it actually should be. So just basically being able to recognize what is full for each sublevel is the key to determining if something is ground versus excited. Are there any questions on that part? Awesome. Okay, so with our lab, what we're actually doing is observing this piece of it. So the summary says that for an electron to go from the ground state, its normal electron configuration state, to an excited state, what needs to happen is that the atom, or the electron really, absorbs energy. So energy is being absorbed from some kind of external source. It can be a number of different things. And then when the electron goes from the excited to ground state, what that actually means is that we are releasing energy. So the atom or electron releases energy. And when energy is released, the way that we are going to observe it in our lab specifically is through a photon. So that says photon, like photo. And a photon is basically just light. It's like a unit for light that we're using. So light is emitted, so what we see is light. So for sure, one of the questions that I'm going to ask you on your quiz or your test or however we're assessed in this unit, I haven't really decided yet. One of the questions that I will definitely ask you is, when we observe a photon, is that a result of an electron becoming excited and gaining energy, or coming back down from the excited state and releasing energy? And the answer is that electrons go from the excited state to the ground state. So they are releasing energy. So that light is given off as energy is being released. That energy is released in the form of light, which is how we're able to see it. So students often mix this up and they get confused. Light energy can be absorbed by certain things, but that's not what we're talking about in this case. And then this next section down here asks, which electron has to absorb more energy? An electron that jumps 1 shell or an electron that jumps 3 shells? So if I have an electron that goes from here to just 1 energy level higher versus an electron that starts at the same thing, first energy level, and jumps to the 3rd energy level, which one would you guess has to absorb more energy? The one on the left or the one on the right? On the right. The one on the right has to absorb more energy. And then what often ends up happening, if we're observing this like in our lab, for example, when you absorb more energy, that means that it has more energy to emit or to give off when it falls back down from the excited to the ground state. So we would see a color with a higher frequency, shorter wavelength. And we'll talk about waves on the next page. All right, flipping over to the back page of your notes. We'll have one little bit on types of energy up here just so that you can see it, and I'll make a separate video for the electromagnetic spectrum. So this kind of explains where light comes from. So this is a different, I guess, way of wording what we just talked about. So photons, which are light, come from electrons falling from high electron orbits to low orbits. So electrons falling from high to low. Another way of saying that is releasing energy. As light. I'll zoom that in so that you can see. So releasing energy in the form of light is what we are actually observing. Because each element has a different number of protons, each element has slightly different electron energy levels and gives off different colors. So these different colors are what we will observe in our flame test lab tomorrow, or next time I see you. And this fact allows us to tell the chemical makeup of stars. So just by looking at the light that it gives off, or its spectrum, the scientists know which elements are in any particular star.